so this isn't going to be very long. I already have mine, so whatever. Right. So
that's messed up. What?
The bar doesn't open for an hour, or wait, 45 minutes.
You have 45 minutes.
But it doesn't appear to be alcohol open, but then I'll have to pay. Well,
You can keep talking. We'll just get beer and come back.
yeah,
Sorry,
that works for me.
2 hours.
So it'll be like 20 minutes, bro.
Before you chimed in.
Everything I say can be taken wrong.
And will be used against this weekend.
Yes.
All right, so I'm sure everybody here has heard of the term fog computing. This is not fog. This is not about the imaging software. This is because I know that's what you guys wanted to hear about, right? Talking about.
I had such trouble with that. I was hopeful.
It's actually a popular topic.
So fog computing. Anybody want to throw out a definition? Nope.
No, that computer before you have coffee in the morning?
Edge computing. Yeah. Pre coffee, post beer, whatever.
A little bit closer to the mic.
A little bit closer.
Not picking up much on it.
Okay. So, right. Oh, first of all, sorry. I'm Rob, by the way. Rob MacInnis. Hello. I'm CEO and founder at EtherWorks. We're a software research and venture development company down in New York City. We're here on behalf of EtherStore at the moment, but our broader interests include distributed computing and fog computing. We recently got a patent in the area for this realm of stuff for using microservices and latent computational resources that are sitting around either in your office or nearby. And you know that for me really is the heart of fog computing. It's not cloud computing. It's not local only computing. It is utilizing the computational resources that are most geographically appropriate, which is to say that if you're just recording historical data and latency isn't a problem for you, cloud, awesome, great, cool. You can stick it in Glacier and post-process it whenever the heck you want, a month later, 2 months later, 3 years down the line. If you are in a manufacturing facility and you've got a temperature sensor on something that is, if temperature spikes for 5 seconds, 10 seconds, that thing is going to be trashed. You need a little bit of a tighter loop when it comes to responding to signals and sending an actuation response. A little bit tighter. Just a tiny long day, right? So for me, it's the appropriately managed geographical proximity of computation and data. And fog needs to provide the systems, services, and architectural framework to enable computation to happen either very, very close to where data is being produced or far away, depending on the use case. So, right, what is a bad example? What is currently going on that could be benefited by some fog style architecture? We've got a temperature sensor in our office called is this being recorded? Let's call it Temp Atmo or Net Temp or some combination of the two. It pumps out CO2 levels, which is really helpful, by the way, in sealed buildings in New York. But CO2, temperature, barometric pressure, and I think decibel level, which is always high in the city, every 2.5 seconds. I don't know about you, but I don't care. That decision comes down to an engineering decision. And guys who write software these days see the cloud as just this place to dump stuff, right? So they're writing software and they're like, all right, we'll just throw all the results in the cloud. It's just the cloud. There'll just be one of them. We've got 4.9 billion connected IoT devices as of last year. We're at 6.4 billion already this year. That's just about the human population of the world. 50 new million new connected IoT devices every single week this year, is according to Gartner and Cisco. 25 to 50 billion IoT devices by 2020. That sounds far away, but that's actually just 3 years away. 2020 used to be it's like 2020 sometime. It's literally in 3.5 years. So, what kinds of problems does this create? It creates massive bandwidth problems, right? There are latency issues. It creates incredible cost issues. You've got an office, you got something like this, you have temperature sensors. I hate temperature sensors, obviously, but there are better examples. Pumping out data that is basically useless, doesn't need to be acted upon right now, could be sent in a more intelligent way. You could have a delta of a 1 degree up or down, and it never sends it, except for once every 10 minutes, and that's the it's still on indicator, unless it goes above or below. Anything more intelligent than just dumping data to the cloud all the time. Because as it adds up, that bandwidth cost, which used to be a real big concern in the late 90s, and they kind of dipped down as concerns go, and with all of these devices around now, that is going to be a serious, serious cost. Next in line is the transaction cost, whether it's AWS or wherever else you're putting your stuff in, and then the long-term storage. What are you going to do with it? What are you going to do with all this data? We don't care what the temperature was, August 12th of last year, or the decibel reading August 12th of last year, and yet NetAtmo is recording this for us, and they're paying for it. So I don't see I don't actually understand why they would be doing that. They're paying for the transaction cost. They're paying for the storage, for the long-term storage. So whatever we paid for this device, $100, their profit margin is swiftly going down. It's going to go past zero, and it's going way past zero. So, right. So, cloud isn't going to solve these problems, but what can? Well, you can create another problem. You can stick a server on site, right? That's the solution, right? Just get a new server, right? Put it on site, or a parrot, yeah, or a parrot, and a parrot too, just for be fun, yeah, or macaw or something like that, yeah. Okay, then you got the cost, you got time. You guys know all the problems, but this I don't need to tell you. And you got a central point of failure. And then if you need the data long-term, blah, blah, blah. Cloud is excellent for some stuff. Long-term storage, archival stuff where you don't necessarily have to be there right away. Excellent. Having an extra endpoint, though, not very scalable, as you guys know. It's something else to manage. It's a cost up front. It's a replacement cost, central point of failure. Like, of course, if you could have two, but or a parrot. So what are your alternatives? What are the alternatives to? You could have three, I guess. You could go just cloud and suck it up and deal. And there is an alternative, which is where I really see the fog concept coming to fruition, and it is in utilizing the computational resources that we are literally surrounded by all day, every day. I mean, right now, we're probably slightly unusual. We're more surrounded than anyone else, but we have, many, probably a teraflop of processing power sitting on that desk doing nothing, right? Not to mention a few terabytes, plug for EtherStore. So being able to utilize these computational resources right now, nothing does it. EtherStore does it. The first step is actually to get the IoT sensors to be written to a URI instead of a URL to address services based upon what they do, not where they are or whether they're currently deployed. And this enables you guys to provide nearline computational resources that can be consumed, and then the IoT devices can actually scale over to cloud or to other resources that are farther away. So how do you do that? Well, you don't do it by provisioning VMs. You don't do it by setting up brand new servers, you'll be providing spare computational resources that can be deployed on demand, that services can be deployed into on demand in order to fulfill the data processing needs that come from this plethora of sensors. Or other things, by the way, applications that need to do nearline processing, or just applications that are dumb. Think of an online calculator. Obviously, it's bad. It's a good example and bad example. It's clean. You send 2 and 2 through the internet. You click go. It goes halfway to Mumbai, and then some service does some math and it sends you the result all the way back, right? You can do that closer. And having services, client-side services that are written against the math service, you can certainly have one of those hosted nearby, and that call and response never leaves this room. Now, there's security implications to that, some of which are good, some of which are bad. Scott talked previously about doing trust on an application level, moving it higher up the stack, right? Trusted networks are not necessarily going to be a tight thing moving forward. So, so how do you guys see? We say this. Has anybody run into situations where you have the devices currently, coming up in numbers? You've got your managed endpoints up here, and you've got these sensor devices slowly working their way up. Yep. And you need to provide them access to your network, and you need to think about access control and how much bandwidth they're consuming and all the rest. Those devices are going, and give me 2 years, actually exactly 3.5 years. Those devices are going to outnumber your managed endpoints in your networks. This is going to be a problem, or at least something that needs to be considered and solved. Those are going to be passing data through your systems. If they have actuators on them, they're going to need to have responses. They're going to have to be able to have responses come through, probably asynchronously, so they're going to be listening. It's going to change the way that, the world will interact with systems that you guys manage. And that's not always fun, but it should be really, really fun. Because you don't have CPUs sitting around doing nothing anymore. You don't have to do, specialized, baked deployments just for this one little thing that you want to make work. If it can be written in such a way that you can drop it in your network, you can allow it access to your network, and it can listen for where a service library is, where an active service directory is. And when it gets its first bit of data, it simply makes a call. And that goes to the nearest open spot for that service to be deployed and run and deal with all the data coming in from that node. This is somewhere between 6 feet away, 8 feet, 10 feet, about 10 feet away, to maybe some of the systems in this building or across the street. I don't really like the idea of subsystem clouds, subclouds, energy subsystems or switching stations, but somewhere between here, 10 feet, and a city block is perfectly reasonable and to be expected, and a good solution that enables a service running on that laptop to go away, because the whole thing is dynamic already. It doesn't need that one server that you popped up. It's already written to be functional in an environment where nothing exists to start with. And when something goes away, that's fine, because that's how it started. And then it gets deployed on a different machine. And if there are no machines around, it's cloud, right? Yeah, it's pretty cool. So that's what's coming up.
You're talking more than storage space. You're talking total.
Yes.
Yeah.
Service space.
Mm-hmm.
Ephemeral service space.
Yeah.
Did this kind of brainchild come from the storage solution that you
Or that you have now? Is that where the brainstorm came from, or was it first?
The general idea was latent computational resources. So that's compute and storage. And in a von Neumann design, you've got memory in the middle, but yeah, compute and storage. Storage was an easy, obvious first one. Compute is challenging, both in terms of the containerization, of the sandboxing applications, right? Exactly. It's
Kind of like the SETI project a little bit? Is that the kind of idea that you're thinking?
okay. So I think I was, what, 15 or so when SETI was around.
All right. We get it.
And but that was
Wow. Not the only one.
sorry, I'll probably owe you guys a first round.
At least.
At least, yeah. All right. And I got to say that probably was a big influence on me personally, just in terms of thinking about the power of distributed computation. You've got all these computational resources out there. Some of them are really constrained. You know, I'm sitting there on my desktop, but you string together 200,000 of these things, 3 million, 5.8 billion, or something like that, and you got a lot of power, right? So anytime I see, I mean, our phones, everybody, we've got a ton of phones in here. They're doing nothing. They're not doing nothing, but they're doing very, very little right this second. They could be doing things.
So how do you deal then with load? So for instance, guy's sitting there using his desktop, he's using no resources. So you decide, okay, we're going to use some of those resources. But then the guy opens a spreadsheet, starts running macros on it,
Yep.
and starts pulling data sets. What happens to that service? What happens to that compute power that you're utilizing?
So it definitely goes back to the level of quality service, any QoS guarantees that you want to have. You'll want to isolate, or at least provide some fenced off proportion of processing power in order to be able to support high QoS requirements for applications, right? But in that situation, you put a bullet in it. Just kill it.
Kill it and spin it up somewhere else.
It doesn't need to be. It will be spun up automatically somewhere else by virtue of there being a request coming from the device. Yeah, literally just put a bullet.
So as a use case, could you see like engineering shop distributing a rendering load across a bunch of machines? Is that kind of where?
Rendering loads are good, a very, 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 very good example of grid computing, in that it's the same job being done. It's actually more SETI-like than specifically what I'm talking about. You're sending out polygons to be rendered, some portion of a scene, but you're basically sending out data to workhorse nodes, and they're doing the exact same thing. They're all doing the exact same thing over top of that data, and then sending back results or storing results somewhere that could be grouped together later. It's a similar idea, except that the endpoints will be different services, and the data will be different, and that the layout of the services on those individual physical machines will change over time based upon the current demand from the data sources. So if it was all of Pixar, newest movie stuff, and that's all that was going on, it would be pure render farm stuff. But once that's not what was happening, and somebody wanted to, I don't know, rip a DVD or something, something like that, right? I actually think you probably just distribute that too. Anyway, other things.
So going back to a good example of the temperature sensors, which you love so much.
Best friends.
So that data does not need to spew out to the cloud all the time.
Right.
So what should we do with that data? How would you envision something like this happening? The compute node for whatever that neat company, that wasn't NET, whatever company you exampled there.
Yep.
But should have it go out, it'll hit a compute node, the compute node will go out, take all these various pieces, and instead of throwing it all out over your bandwidth, it'll stay local. they'll compute it, they'll summarize it, and then send that summary to another node or to the cloud or somewhere else, so that we just access the summary later? Is that kind of what you're envisioning for how some of this would handle it?
That's how I see it, yeah. Yeah, absolutely. I think there's there opportunity for local transient resources to be used for data storage, for example, but that are necessarily not reliable. So let's say you start up an application, you want to be able to access actually a more fine-grained level of temperature readings. And there's some storage nearby that this process running in-house somewhere nearby is using to store these temperature readings. By virtue of policy, you're not necessarily wanting to keep all of them, but there are some that are around. You can request the local ones, and actually there may be some nearline, but they're not something that you would rely upon actually being there. Sandia.
So you're talking compute and storage. Let's say you're running the job for the rendering, for example, and you lose a storage node. What happens to the memory that is on that? Then it's the job that's actually running on that node. Does it just migrate over to the remaining systems? Are you risking losing data?
This style of system is written with what are called idempotent operations. They're things that you can run them 30,000 times in the same data and it doesn't matter. Like you're not changing. It's not like a bank transaction that's going on. You need an ACID transaction. So failure of the individual process or individual call doesn't matter. Doesn't matter at all. Simply be retried at another endpoint if one is currently deployed. The great thing about idempotent operations is that you can have 30,000 endpoints, or you can have 1 or 0. Well, you need 1, but 0 would be pretty cool. But, yeah, it's so cool. You don't need it. Yeah, exactly. And which means you can scale linearly, which is glorious. So, any other?
Well, outside of the render farm idea, what other kinds of processes do you see that being extremely beneficial for?
So I mentioned the IoT Winter, as it is, that is coming. My slide deck actually had a Jon Snow thing. It was pretty weird, but IoT really takes focus in terms of what everybody's almost panicking about in regard to fog computing. Personally, I think development shops that are running non-production services who don't need or want to spend the time to set up a server, have it be completely clean and ready for deployment, deploy it by hand, see if the service is working. Oh crap, it's not. Cool. Pull off the service, trash the server, come back, stop the client-side code, etc. To be able to just focus on only client-side code or only server-side code is another benefit of this sort of separation of providing the service from writing the code. So, in general, anything?
Yeah.
IoT Winter is now attacked.
Sweet. IoT Winter is now attack.
I just have to ask, has this, you guys experimented with this with something like containerization?
Mm-hmm. Containerization is Docker, things like that. Very important part of this. So as I mentioned before, the granularity of computation, I believe, is going down, which is to say it's becoming more fine-grained. The deployment of full VMs with a full operating system, the rest, I mean, I think is unnecessary, which is really cool because it's going to free up a whole ton of spare compute, right? Instead of having X VMs running on on a big box, you can actually configure a few to be dynamically, to be available to have containers deployed dynamically within them. So you got one OS. It's good. So.
Do you have it, is it going to be set as like the appliance on top of your hypervisor? So if you start tacking on compute power being sucked away from your ESXi host,
Yeah.
your VMs then are going to suffer.
Yeah.
So is it something that's going to be on the hypervisor instead rather than installing on top of the VMs?
Yeah, that's an open debate. Intel really likes the integrating at the ESXi layer, and everyone else likes integrating at the OS level. So, I mean, there are a ton of, there are a couple of open sourcey projects going on for, oh gosh, I forget the names of them, but to have, sorry?
Is that server KVM?
No, they're more ghetto than that. You know what I mean? This is people in their spare time kind of writing stuff, but it's interesting. Management, as you guys all know, is still a really, really important aspect of this, and like, if you integrate at the OS level, you at least know how to walk around town and actually poke at stuff and you know, clear stuff up. If the thing actually running on the processor is just the container, like, well, you're going to go through BIOS or something. You got power plugs at that point, really, to turn it off. So, yeah.
So going off the premise of what you're looking to do in digital computing, why don't you apply that same rule to your development? So you just find more people with spare time to
That's good. One of the best things, probably why I went into computer science in the first place, is that computers do exactly what you tell them to do. And I haven't exactly and only what you instruct them to do. And if they don't do it correctly, it's your problem. It's your fault. It could be other people's problem actually, but it's your fault. There is no corollary for that really in the human world. So, yeah. But I like that mechanical Turk. Yep.
So, with what you're suggesting, as it came up here, Sandia Ready, it was pretty much the first thing that popped in everybody's mind. So, you're gonna have to sell this to IT departments. How are you going to get us to allow random nodes to be spun up? Because I'm gonna run this solution, and it's great for my work, so I can have my random compute stuff in my office doing it. But your vision, what you're talking about, means, well, if my stuff can't reach it, it's going to go to the next one it can find, which is in the building across the street. So how can you present the security that I can understand, I guess, because of what we do and how the conversations we have about
But explaining it to...
security is there, but how do we sell that? How do we make this work? How could this work to get that out there?
Well, and let me add on to that. There's more than just that. There's also the extra power draw that you're now costing someone else, the internet bandwidth that you're costing somebody else. So if you're going to borrow from non-owned assets, that's a pretty huge deal.
So,
You're paying us instead of us paying you.
But SETI does it. So the answer, how do you do it? It's called good marketing. It's you make a logo that looks and sounds green, and you say something about saving the whales. And suddenly everybody wants it on their computer.
Oh, it's Windows 10.
But yeah, no, it's Windows, not Mac. So you're ruining
Now,
the learning.
Rob, if I'm not mistaken, your tool won't go out to your other customers. It's only going to work within the individual appliance space, right? So any systems that we personally own as a customer to you, everybody, right?
specifiable. So, and that's by virtue of about 3 years of customer development that we've done. That it was headline conclusion was that people, like, regardless of the fact that data is inert, it's not going to hurt you. They don't like other people's data on their systems. They don't like the idea of it. Similarly, you can explain encryption till you're blue in the face, and they don't care if they don't want their stuff anywhere else, right? But they're okay having it on cloud or you know, as you guys say, like somebody else's other people's computers, right? So,
Magical.
right, yeah. It's safe, yeah. Is there something called Magic Cloud? There should be.
Did I just come up?
I think so.
You gotta find some
Trademark.
Yeah. Yeah.
With a unicorn is the, on a cloud.
Yeah.
Farts.
Yeah. It's good.
Cloud powered by unicorns.
Oh my God. So if you've got like a couple of offices in town, right? Having those compute resources listed, and then if you've got a contract with, you know, your AWS or your Azure, having those be next in line for where to deploy. That's how we see the ACLs basically working.
It seems like a logical extension that there would be a significant opportunity in a managed marketplace for fog compute resource availability. So a customer could be like, well, we want to charge, much like the spot marketplace for Amazon for AWS services, right? You could be like, well, we have these resources available, we're going to advertise them, and they're at a penny an hour. And then people can say, well, I'm willing to go out at these prices or whatever.
Yep.
Yeah, that's cool.
Absolutely. Absolutely. You can bring your own compute, or you can
Right.
utilize it.
From
Yep.
across the
Rent
street
some.
or-
Yep.
If it's good enough, MagicCloud.com is available for $25,000.
You have to work on the logo first.
Yeah.
We'll see how marketable.
Okay, at the bar.
Yeah.
Yeah, cool.
Exactly.
I'll bring paper
Okay, awesome.
and stickers. And
And plastic, right?
careful.
I'll bring the glitter.
I'm right here.
No, that was the, okay.
Rubber boots and
Yeah.
So what are you currently doing today with your product?
That's good.
In order to reach the public market space, like as was just discussed with, hey, if you're an Ether Store client and you want to rent out some of your computer and your storage space, is there something that you're currently doing for that? How are you marketing that?
This is actually the first time that I've discussed this publicly. We got a patent for basically what you just said a couple of months ago. So this is actually the first time that I've shared this out loud with a group of people.
Sorry, you did not tell me that.
No, I didn't. No. With Ether Store, we do not currently do, and we have no plans to offer the opportunity to rent your storage space to someone else. We see the major benefits of the storage space being on site. Right? There are, as you guys know, a zillion benefits that not only access time, but you get cut off from anything, recovery times, RTOs, blah, blah, blah. Yeah. So there are different qualitative benefits to Ether Store that are not just cost, even though, again, actually I was going to announce this, and I'll announce it tomorrow morning. So, yeah, you got to come, 9 o'clock. 9 o'clock.
Now I gotta be awake and here.
Yes, I'll see you like 9:15.
She's making you.
Yeah, I'm probably the riskiest one there as far as, yeah.
Okay, recovering.
Don't worry, I'll stall.
Totally unreasonable.
I'll stall her.
Yeah,
It's
good,
okay.
good. Cool.
So at what scale, so for the SMB space, which is kind of, this is a SMB conference,
Yep.
at what scale do your SMB customers come in at? Do they start with, oh, we've got 2 or 3 servers and we've got 150 desktops? Where about is that?
Inside of that, to like sort of one box and 20 endpoints, or even 10 or 15, up to, you know, we see it like, you know, like 2-man shop, right? Is where we're comfortable. I'm comfortable talking to you guys. We know what's important. It's actually really easy to talk to you, to ask you things. You know, that's horrible. Right? So this is sort of our comfort zone as far as that goes. Higher than that, we know and talk to a whole ton of people in sort of your super enterprise Fortune 500 range, mostly for sort of long-term view type stuff, or, you know, every once in a while, like, so is there any chance this could be like a, $50K a pop for a little tiny bit of software? And it's always a no, but yeah, mostly, your standard SMB range, possibly somewhat on the small side, squeezing down, then up to, inside of 500.
Do you find that diminishing storage prices hurts that model?
We, again, provide a number of qualitative, having on-site storage is simply a benefit. If you've got it, it's sitting there, you've already paid for it, right? Makes perfect sense. Cloud storage is, the fact that you literally can and often do get disks shipped to you through the mail because it's faster to pull the backup that way is silly. If you simply utilize the spare storage that you've got on site, you can be up and running. You just click a button and it mounts the drive. Like, that's it. So there are many, many, many benefits of being on site, and at the price point that I'll tell you. So we're announcing a freemium model that enables everybody to at least try it out for free, and then we're going to do direct sales at a couple bucks per machine per month to enable you to make use of all of that spare space. So there are a couple more details I'll share tomorrow.
And I know a partner that does it.
Did you? So, yeah.
The only plug I've done for free.
I like it. It's good.
I'm allowed one.
Well, and obviously I've known about the shared, the storage end of it for quite a while, but having the compute, I know lots of companies that do engineering or software rendering, any sorts of those jobs, being able to make the power of every computer that's sitting there available for jobs running that is just game changing.
It really does sound amazing. I can't imagine someone like IBM or these huge companies with thousands of computers not wanting to take advantage of this.
I mean, even our size. I mean, we're departmentalized, and we have an engineering department. We have a couple of CAD drawers, and they'll render stuff. And I'd love to be able to suck up compute from desktops that are idle, doing nothing.
Yeah.
I mean, literally doing nothing.
One of the staggering differences is when we're normally talking about this kind of stuff, say AWS Spot, you want to do, so my background, right, finance, you want to do stuff on AWS Spot, you're paying a premium because you're doing Monte Carlo simulations or something, and you're doing them on
GPUs.
You'll use them on idle, but then you're getting CPU resources mostly from Amazon.
Or GPUs sometimes, which you can actually use.
Right, you move to desktops, and you have idle GPU in most cases. And the level of teraflops available for single point operations goes through the roof. And so if you're doing Monte Carlo simulations are like the sweet spot, suddenly you're going from, I could be paying $1,000 a night on AWS and struggling to get stuff out in the morning to, oh gosh, I'm sucking up my own idle desktop resources overnight and getting the same stuff because the GPUs are going at 1,000 times the speed.
Right.
Yep.
Yeah, that's.
And then it becomes
I do ask the question about the power consumption difference there, though.
Yeah, but when you're comparing to, I mean, I'm literally talking about $1,000 a night is the kind of numbers. Like, so when I was in banking, what we built, this is a decade ago. So the amount of computational resources you needed for a nightly run of Monte Carlo was quad CPU systems, probably quad core CPUs per one, probably 32 gigs per node, 10,000 nodes, right? That's a lot of power, no matter what. And you can shift that to Amazon and use spot pricing, and spot pricing lets you do, I'm going to wait till it gets really, really idle and then buy more of it so that you're getting a better price because you can let the latency drive a value. But even in doing so, the Amazon's going to cost more than building your own unless you're running it significantly under 20 hours a day. But by moving to the desktops, if you can get enough done, and you don't have to get it all done, right? Because you could split the load, do as much as you can in-house, go off to AWS. You can create a buffer layer that's like, well, our desktops can do 80% of our load. We're going to build out a 10% dedicated load just to make sure we're not spending too much in AWS, but then let the fluctuation be sucked up by AWS, right? And you can get, no matter what it cost in power, someone was going to pay that, but you don't have to pay the data center team and the WAN cost and the, right? So it's,
And the power is generally medium. The cost of the power is so low that, realistically, you're powering those desktops anyway. And the increase in power consumption.
But are you in a big company like a bank? I mean, they've got 1,000 computers. I mean, the big thing today is to turn them all off at night. They're not running at night. They just power on with wake on land type situations.
that's not out of the question.
No? Okay, so, I hear that that's the big thing, is that, we're supposed to be all
It's a great
green
theory.
today. We want to turn all these
Great theory.
computers
These are
off.
really the same.
So maybe it's a fake economy, and it's really not a big deal.
It's totally a fake economy because the cost of power is so cheap.
Yep.
You're talking pennies.
Yeah, and people do maintenance during the night, and people work all kinds of hours.
Well,
You
sure.
can do wake online stuff. You absolutely can. It's just a lot of people don't.
Okay, well, I mean, yeah, it's just one of those buzz things that I'm not in the environment, so I'm not sure what's really going on, but it's just what you hear.
Yeah. Banks are definitely like, oh, did it save you 1 minute in the morning coming in? That was totally worth the power all night. Are you less annoyed that you have to hit the power button? We don't care.
Yeah.
User experiences.
User experience is where it is, and okay, so you turn computers off at night, and now suddenly they're getting prompts and reboots and downloads and updates during the day. Oh, screw that.
Yeah.
Exactly.
You know, whatever else. So yeah, no. So like as Paul says, the compute's there. I've got clients. Every single one of my clients leaves their stuff on all the time. Well, because they know I also log in at random times at midnight after I've been drinking. But that's not safe. Yeah.
Or 5 p.m. I don't know.
Hey, all right, add that. There goes some Windows updates. But we handle all this at random hours at night, because it doesn't impact them during their business work.
Right.
And where if you have them turning it off, and I had an example, one office started calling me 2 months ago. Man, we're just having so many problems with speed and slow, and it's like, well, have you guys been leaving everything on all night? Well, no. We always turn it off. Don't. They got a 5 meg connection, and they're pulling down Windows 10 multiple updates. Hello.
During the day.
Well, yeah.
Well, yeah,
They're off
they're off at
right.
night, yeah.
So so long as saying the power doesn't even matter compared to that user experience.
And the reality, I think the reality of what Rob is talking about is that you're using idle space on computers that are already on because people are working there. They have a document up and it's just sitting there. They're just
Absolutely,
Or they
during
go
the
to
day.
lunch.
I totally understand that
Yeah.
during the day, absolutely. That part's a no-brainer.
Yeah, because absolutely no one's using their computers during the day, because they're always talking about fantasy football.
Rendering cat video takes a long time.
Actually, that could be a really interesting quality of service thing. Detect Facebook and then take over CPU.
Do you have plans to incorporate graphical views of being able to see, okay, how much compute space do I have available at the moment? How much what's my capacity?
Yeah, we instrument our daemon process already for checking CPU at a pretty fine grain. We actively don't interfere. So we set the processor affinity to a single core, which helps. And then there are certainly a lot more things that we can do around actively undeploying things, but we don't, because we don't mess with things. We don't see that we actually interfere with the usability on a day-to-day basis. So it's good.
How are your clients currently deploying in their businesses? Do they have to walk around each machine in GPO? Do you have MSI? Or what do you
It's
got?
just an MSI.
Just MSI?
Yeah.
And with looking at automatic deployment through,
Choco. Anybody use Choco? Yeah?
Yes.
A package manager for Windows.
Awesome.
It only took 35 years.
Still can't get that up to all at once though.
Yeah.
May I have to ask any plans for Linux Unix world?
Absolutely. 99, I'll just leave it at 99%, but higher than that, of the guys that we've spoken with over the years are the vast majority of the systems they work with are Windows, almost exclusively Windows environment. So for a business like ours, support is a big deal, and tripling the amount of support coverage that we need to be able to provide, and the education for people to know. You know, I know I can support all this stuff, but I actually wouldn't be 100% certain that I could support all of our Linux stuff, to be honest. Most of it's all written in Java, except for the some of the user-facing things, like the who here knows what Fuse is on Linux? Okay. So we use a Fuse clone for Windows to mount the drive. So that's clearly a Windows-specific thing, but most of the rest of the stuff that we write is in Java, and then compile down to a particular target, and then we ship it with the VM. So,
Have you, so obviously...
Sorry, a VM, like a JVM, not like a... Yeah.
So there's a really big, obvious push for things like truly ephemeral services where Monte Carlo simulations, SETI would work, that kind of stuff. Have you considered or looked at or have plans towards what I would call semi-ephemeral services, such as, you wouldn't want to do this for public facing, I'm sure, but for internal use, like web servers, that using fog computing and saying, well, we don't need, we probably need to have a database somewhere, but mixing kind of a traditional, the last 2 years, right, traditional DevOps model of automated deployments, which we're already doing for stateless systems, right? So web servers, or web application servers are the big thing. If you did the same thing with fog computing, if you did it for public facing, you may face scale up time issues or latency issues if you went down to 0 because things were idle. You may be willing to do that, but a lot of places would not. But for internal use, a lot of things may be very, very well, we want to have this really light web service internal to a larger organization, and simply say someone's desktop or whatever is idle, throw up an application server there and let it handle those requests instead of, it's kind of the same workload, but it's not exactly.
So for static, if you're just chucking static stuff out there, I guess in both situations there is a data proximity thing. Are you shipping the entire package? Are you shipping the application server plus the data with it, or are they referencing it?
I'm thinking of stateless systems. If you ship stateful with the
then
database,
you're fine. You can just scale out to make a zillion things. I think, as you mentioned earlier, you don't want anybody touching. Like direct database connections are just ridiculous. So sticking a service in front of that is imperative. And yeah, this absolutely helps with that kind of stuff. For various use cases, we seem to have a few that you guys have come up with right off the bat. I'd love to talk about all of those. I'll be here all night. Try the fish, I guess.
As soon as I find the bartender at 6 o'clock.
Yeah, all right. Cool.
It's not 6 o'clock until you find the bartender.
Thanks.
6 o'clock somewhere, wherever the bartender is.